In our last video, we had a look at calculating z-scores. In this one, I want to have a look at how we can use those z-scores to compare data from two different data sets. So to do that, I want to have a look at this example. So we've got Ashley's marks for 3 exams, and we've also been given the class means and standard deviations. So if we just look solely at her marks, it looks like she's done the best in maths because she's got an 80, and it looks like she's done the worst in science with that mark of 60. But that might not be the case. Maybe maths was just an easy test and science was really hard. So we have to consider the bulk of the rest of the data, so how everyone else did as well. So if we look at the mean and standard deviation, we can calculate the z-score for each one. So remember, the z-score was the raw mark minus the mean divided by the standard deviation. So for maths, the z-score would be that 80 minus 75 divided by 16, which would give us 0.3125. For science, the z-score would be that 60 minus the mean of 54 divided by the standard deviation of 12, which would come out to be 0.5. And for history, the z-score would be that 70 minus 78 divided by 10, which would give us minus 0.8. So from that, you can see that she's done above average, so above the mean, in both maths and science. And she's half a standard deviation above the mean in science, which actually means that she's done the best in science, even though it was the lowest raw mark. And in history, she's actually 0.8 standard deviations below the mean, so below the average. So that makes history her worst one. So her best mark was in science. So comparing z-scores is really important because it's a really valid way for us to compare data from different data sets.